uploading live to YouTube right now.
Oh, yeah, check it out.
We'll see. All right, so here we go. We are doing P3, and we're still solving some different kinds of linear equations. So, I don't think any of you have issues with solving this kind of equation, except you try to go too fast sometimes and you get careless. So, what would be the first thing you would do when you look at a problem like this? This is P3 number 3E. So what do you think? You're going to distribute. So 15z minus 9, and you're going to be real careful here. This will be minus 8z minus 4.
Yep.
And then we're going to collect like terms. So 15 minus 8 would be 7z's minus 13. And then add z minus 2. Everybody still with me, okay? You know what to do. So 2z equals 11. Did I do that right since I'm on live TV?
Yeah.
Okay.
Wait.
No? Yes?
Yeah, you did it. You did it right.
That's right.
All right. Not too bad. Let's look at the next one. Same thing. These are easy little equations. Everybody knows how to do this. We always have options, but what might be a good way to start this? Multiply by 3. Now, when I multiply by 3, I got to make sure I multiply both of these by 3, right?
Yep.
So that's going to be 6z minus 12, and then I have 4x minus 5. Remember, when you times by 3, kids, that cancels. So that's just 4x minus 5. So then I've got 2x. How do I get x's and z's? That's an x. So I've got 2x equal to 7.
Yeah.
So I got 7 halves for that one.
Yep.
Got it? All right. Oh, this looks like a mess. Well, if we're having a hard time getting started this morning, this is a good one to get us going. That is a real mess. What do you think about that? What could we do that might, we could multiply everything by 12? Now you might think, well, that's an extra step, and it really is an extra step, but it's going to help us get rid of a bunch of stuff, right? So we won't have to deal with those fractions anymore. So be careful. 3 goes into 12 4 times. So here you're going to have 4t minus 4. 4 goes into 12 3 times. And here we have 3t plus 15. And 2 goes into 12 6 times, so here we have 6. So we started out with kind of a messy fraction that we would have had to have gotten the common denominator anyway to do the addition. So it's just as easy to or easier actually, to multiply everything by the common denominator, which is 12. And then we have a regular equation. So 7t's plus 11 equals 6. Keep an eye on my arithmetic. So 7t equals negative 5, and I got negative 5/7 as my answer. We don't have to multiply everything by 12, but it sure did make that easier, didn't it? All right, next page. Oh, now we have the same thing, but these are inequalities. Now, is there anything additional we need to know about solving inequalities, or are we gonna do all the same stuff that we've been doing all along? Ms. Piper?
You have to put this on the divided by negative.
Exactly. Everything stays exactly the same, except if you are going to divide or multiply by a negative, we have to remember to switch our sign. Adding and subtracting, no problem at all. So let's go ahead and move some stuff around. So this would be negative 2x and 4. So I subtracted 4x from both sides, and I added 1 to both sides. Now, you might do things in a little bit different order, but the idea is you gotta get all the x's together and all the y's together, or all the numbers together, just like you do with a regular equation, just like we did here.
Oh, wow.
Everybody with me still? Now we're gonna divide by negative 2, but that's what she was talking about. If you're gonna divide by negative 2, that switches. So your answer is everything greater than or equal to negative 2. Once in a while, the directions will say, answer in interval notation. This problem doesn't have any directions, but sometimes there are directions, like in the textbook, it says answer in interval notation. So what would that look like as an interval? You did this on your quiz yesterday, some of you. What does that look like in an interval? Bracket at negative 2, and then not 0, infinity, and a
Bracket. Oh, no, wait.
parentheses. Remember, infinities always get parentheses. Infinities always get parentheses. If you drew that on the number line, you'd have a closed dot at negative 2 and shade everything this way, right?
Yep.
When you shade that way, that means we got a positive infinity out there. So this is the answer, but this is the answer written in interval notation, in case the directions would say that. How about this guy?
Subtract 6 from both sides.
We'll subtract 6 from both sides. Now, some of you might think that's a little bit tricky, but you can do that. That's completely legitimate as long as you take 6 away from this number and from this number. So what's left in the middle here? If we take that 6 away, all we have is an x, right?
Yep.
Which is perfect. That's what we wanted. We wanted to know about x. So this would be negative 4, and this would be 3.
Yep.
So again, if the directions happen to say answer in interval notation, what would this look like in an interval notation?
Oh.
We have negative 4 and 3, a bracket on the negative 4, and a parentheses on the 3. Now, this is the right answer. This is the right answer. It just depends on which way you're supposed to write it. This would be in set notation, this would, or an inequality notation, and this would be in your interval notation. Okay? Right, that was easy. Wasn't hard at all. I don't think the next one's very hard either. What do you think? What would you do here? Maddie, how would you start this problem? Distribute. Alright, so that's easy enough. So 4 minus 4x and 5 plus 5x. Malcolm, what would you do next? Okay, because you want to get all the x's together, you might, that's okay, that would be perfectly fine, but you might want to clean this up first. There's a lot going on over here, and it might be easier to go ahead and fix all this first and then start moving your other stuff around, but it would be okay to bring the 3x over. I think it's easier to go ahead and combine this I did it right. I have a 4 and a 5, and a negative 4x and a 5x. These are all over here on this side, so I'm just collecting like terms. Now I'm going to do what he said and subtract this 3x. Now I can move that 9 over. Negative 1 minus 9. Negative 10, very good. Oh, watch it, watch it, watch it. I'm going to divide by negative 2, right? So those of you that are working ahead, did you remember to switch the sign so that your answer is x is less than 5?
Why don't you just subtract the smaller amount?
Yeah, why didn't you, yeah, that's what I did. I subtracted the x, and then got 2x, and then added the 1 over,
Okay.
10.
So then what did your answer look like?
5
5 is greater than x. These are the same thing, aren't they?
Okay, yeah.
These are exactly the same thing. Now, here's why I like to do it this way. Now, there is nothing wrong with this. This is the absolute 100% correct answer, no problem. However, if I am graphing my answer, if the directions say solve and graph, or if I have to write it as an interval, I want to be real careful about this, because I'm used to seeing that symbol and thinking I'm going that way with my graph, right? But I don't. If your equation's backwards, this is considered backwards, it's fine, but it's considered backwards because you have the x second. If you graph that, make sure that you are graphing it the right direction. So even though you see that symbol, it really means this. And if you write it as an interval, it really means this, okay? So no matter how you solve it, this would be the picture and the interval. So just be careful. This is absolutely correct. You can do that. Makes no difference which direction you move things. Yeah, it's a great question. Thank you for asking that. It's a great question. This says x is less than 5. This says 5 is bigger than x. They are the same thing. All right. How about this guy? Don't be tricked. What are you going to do to solve that? Multiply by 5. Now, am I going to switch that sign? No, because I am not multiplying by a negative. I'm getting a negative answer because there's a negative over there, but I'm not multiplying by a negative. I only switch the sign if I am multiplying by the negative. That doesn't change. I'm going to divide both sides by 3 now. Should I switch that sign?
No.
No. I'm dividing by 3. The fact I have a negative over here doesn't make a bit of difference. If I divide by a negative, I switch the sign. I didn't, so I don't. All right, now letter E. Miss Pavanka, you got a plan for letter E. Multiply everything by 6, because 6 is the common denominator, so that makes perfectly good sense. I'm going to multiply everything by 6. Now please be careful. Why did you multiply by 6? So that you could get rid of the denominators, right?
Yep.
So you're not really multiplying by 6 here. You're really multiplying by 3, because 6 over 2, right? So this becomes 9 minus 3x. Now similarly here, you're not really multiplying by 6, you only end up multiplying by 2. So 10x minus 4. And then over here, you really are multiplying by 6 because there's no denominator to cancel it. Malcolm, this is the same situation we had in your problem. So before we start messing around with it, let's clean this up. So we have a 9 minus a 4, so that would be 5. And we have a negative 3x and a positive 10x, so that would be 7.
Mine's 5.
Subtracting 5 from both sides,
Negative 11.
negative 11, and then
You get negative 11 and 7.
divide by 7. Do I switch the sign?
No.
Nope, because you divided by a 7. So x is less than negative 11 sevenths. Interval, what's that look like in an interval? I have my negative 11 sevenths, what do I write? What goes with that in an interval? Think about which way it's shaded. Wouldn't it be shaded this way?
Yeah.
So what goes over here? Negative infinity. What goes, what symbol do I use out here? Parentheses on both ends.
Yes.
Open dot on the 11 sevenths, and
Yep.
all the infinities get parentheses. All right, one more, and it is a doozy. Oh my, we could talk about different strategies here. This is really a mess. You okay? Jalen, you all right?
Yeah, I'm fine.
Okay, good. Now, I think, even though it's full of fractions, I'm gonna go ahead and just distribute. So 1/2 x, 3/2, 2x minus 8, 1/3 x minus 1.
Wait. How did you get this 3 over the 2? And then,
1/2 times 3.
oh, okay, yeah.
Remember when we multiply fractions, it's straight across, so this is
Yeah.
3 over 1. Now this is a mess. So I think I'm gonna multiply everything by 6. I could have done that at the very beginning, but when we multiply and there are parentheses involved, we end up getting confused and making errors. So I chose personally to get rid of the parentheses first. And now I'm gonna multiply everything by 6. So what do I get right here? Remember, you're timesing by 6 for a reason. You get 3x. Here we get 9. Remember, you times to get rid of the fractions. So this becomes 9. That is just 12x. This is just 48. You're multiplying by 6. What's this one? You're getting rid of the
2x.
fractions. 2x minus 6. So it's still big and it's still, messy, but it's not as bad because there aren't fractions anymore. We times every single term by 6. You aren't allowed to multiply only some of them. You have to multiply all of them. So I got 15x minus what? What's that? 39? So 13x, 33? Is that right? If I subtract 2x and add 39? 33 thirteenths, x is less than 33 thirteenths. Does that look okay, or did I make a mistake? I did that right? What a relief, since we're on live. But I probably shouldn't worry about it because I normally only get 1 or 2 views anyway, so it's not like the whole world is out there watching Alpha Theory Precal. Alright, so here we go. Now we're gonna talk about something really, really important. We're gonna talk about equations of lines. Who remembers how to find slope? Who remembers how?
I don't know,
Okay,
it's
now,
slope intercept.
Y1 minus
somebody said y equals mx plus b. We need that, that's important.
It's slope intercept.
But that's slope-intercept form. We right now are talking about how do we find slope?
Y2 minus Y1 over X2 minus X1.
So, Jalen says, subtract your y's, subtract your x's, put the y's over the x's. I am not real big on memorizing a bunch of formulas. You need to remember that slope is the difference in y over the difference in x. So, the difference in my y's is 8 minus 2, and the difference in my x's is 6 minus negative 1. So my numerator is 6,
Over 7.
and my denominator is 7. So the slope of that line is 6/7. So if I were taking this one step farther, if I were actually going to write the equation of the line using my slope-intercept form, 6/7 is what would go right here. M is 6/7. Gentlemen, I'm getting ready to absolutely wig out on live TV. Okay, how about B? See if you can do B and compare your answer with your neighbor. See if you guys can get the same answer. We're finding slope again. We're finding the slope given these 2 points. Go ahead and do that. See if I got -1. Is that what you and your neighbor got?
Yeah.
Now, did I do things a little bit differently than you did, or did you do it exactly the way I did?
It's different.
You did a little bit different. You subtracted 1 minus 10
Yep.
and 6 minus -3.
Yep.
Now, ultimately, did it matter? No. So while you have memorized this right here, and that's fine, that will work every time, do not fret. What's really happening is you gotta subtract your y's and you gotta subtract your x's. And the order that you subtract them doesn't matter as long as you do it the same for both. So if you did y2 minus y1, then you have to do x2 minus x1. But if I do y1 minus y2, then I will have to do x1 minus x2. Do you see what I'm saying? The order doesn't matter, but you gotta do them both in the same order to get the correct slope. Very good. What?
Why do you have to do one or the other? You can't do both.
Because when you find the slope of a line, you are talking about, when you think about it, you're talking about how do you move? Slope is like a vector. How do you move to get from point A to point B? So if you are asking yourself, okay, I gotta get from here to here, then you're moving the same, you're taking this y and getting up to where this y is, and then you're taking this x and getting over to where that x is. Or you could do this and this, but you have to have the same starting point if you're getting from point A to point B. All right, now, we're doing the same thing, except they're telling you that the slope is 3/4, and you have to find the missing coordinate. So what do you think, Miss Piper? You got a plan? I'm trying to think if that is exactly what Yes, yes, that would be perfectly fine, and I think it is essentially what I was thinking anyway. It might be a little more complicated, yeah, it might be an extra step or two, but yes, absolutely, that will work. Now, some of you are thinking, what is she talking about, point slope? God bless her for remembering. Somebody earlier said y equals mx plus b. That is what we call the slope-intercept form of the line. But there are other forms of lines. This happens to be our favorite a lot of times, but there's other forms. One of them looks like this. Does that look familiar to anyone? That is called the point slope form of the line. Both of these write equations of lines. You just have to follow the directions. And in the real world, there aren't directions. So when guys who use math for a living have to come up with a linear equation, nobody says you have to do it this way. They do it whichever way is easiest for them. Now, what I was thinking, Miss Piper, is I know that slope is y minus y over x minus x, right? Y minus y over x minus x. And I know in this problem that when I do that, I have to get 3/4. So what I was thinking was this. What you were thinking was this, which actually isn't going to be any extra work, I don't think, now that I actually look at it. These are the same thing. This is just multiplied over to here. So what your idea will work absolutely. I don't want to confuse any of the rest of you. If this makes sense to you, great. If this makes sense to you, great. I use the slope formula, y minus y over x minus x, and said, okay, that's the slope, so that must equal 3/4. She used this and plugged in everything but the missing x. Now, I kind of like my way better, a little bit, because I'm going to cross multiply. So that's 1. This is just 1, 6 minus 5. So when I cross multiply, I'm going to get 4 equal to 3x minus 12. And then 3x equals, yeah, and x equals 16/3. You'll get the same thing when you work this out. I guess your way does require a little bit extra arithmetic, but not bad at all. You get the same answer. Good thinking. Good thinking. All right, let's try one more of these. See if you can figure this out. Help your neighbor if you guys get stuck. Let's try finishing up this page. We know 2 points, and we're going to find that missing coordinate if the slope is negative 2/3. So see if you can figure that out. I'll do it up here in a minute. But the slope, so think about how you find slope. What do you do to find slope? Subtract your y's, subtract your x's, and set it equal to negative 2/3. So y minus negative 2 over 1 minus 3, that's slope. Y minus y, x minus x, and set it equal to negative 2/3. Does that make sense to everybody in the setup? Yes. Okay, let's solve and see what we come up with.
Oh my gosh.
Coincidentally, I got negative 2/3.
No, so did I.
cross multiply here, make sure you distribute, so that I got 3y plus 6 equals 4, negative 2 times negative 2. Did I multiply by 6? At this point, I could have, but I didn't. I cross multiplied. Yeah, the result would be the same, but I just cross multiplied. Anytime I have, this is called a proportion, a fraction equal to a fraction. Anytime I have that, I cross multiply. But the effect is the same as multiplying by the common denominator. All right, are we okay with that? We have a couple more things to do. Then we got to do a quick review because we are going to have a quiz next time we're together. Woo! So we're going to review a little bit for that. We got a couple more things to do.
The grind doesn't stop.
Okay, so here we go. Write the equation of the line. Using point slope, write the equation of the line through these two. Now, gang, fractions are part of our lives. And unfortunately, we're not going to be able to get rid of all of the fractions when we're talking about lines now. So we're going to have to deal with it calmly. We can do it. So here we go. I want to write the equation of the line. One of the most fundamental problems in mathematics. Write the equation of a line. You've got to have the slope. So step one is what we just talked about. Find the slope. So what's the slope of this line going to be? 4 minus 2 over 6 minus negative 1. So someone said 2/7. That's it. That's your slope. Your slope is 2/7. Now these directions say use point slope. So point slope is that form that says y minus y sub 1 equals mx minus x sub 1. M is your slope, and x sub 1 and y sub 1 are your point. That's why it's called point slope. There is room for a point, and there is place for the slope. Now, I know I'm going to use 2/7 for my slope. What am I going to use for my point? I can pick one. So I don't like negatives, so I'm going to go ahead and pick this point right here. It doesn't matter. Our answer will be exactly the same. This is my x sub 1, and this is my y sub 1, my point. So y minus 4 equals 2/7 x minus 6. I have a formula, and I am just plugging in my m value that I figured out, and my x sub 1, y sub 1, my point that was given to me, I'm just plugging it in. Everybody with me so far? Right, now we're going to clean that up. Sometimes it's okay to stop here. Usually it's not. So we're going to go ahead and clean this up. And by clean it up, I mean we're going to distribute the 2/7. What happens when I take 2/7 times negative 6? 12/7. Now I'm going to add that 4 to the other side, and this is where we've got to deal with the fraction. There's no way to get rid of it. So we're gonna add 4 to both sides. So I need to add a negative 12/7 and a 4/1. And the only way to add them is to get a common denominator. So 7, 1, I guess the common denominator is 7. So I've got to multiply this by 7. So that it's 28/7 now, and that's a positive 28/7. And a negative 12/7.
Oh, 16/7.
So that would add up to 16/7. Now, that is unpleasant, it's tedious, but it's what we gotta do. Anybody have a question about that? What?
Before you do any of this, you slow.
Yep. You cannot ever, no matter whether we're doing point slope or slope intercept, you can't get away from finding the slope. The slope has to come first. You need the slope.
Before you even add the 4, did you multiply everything by 7 first?
You could, but then remember, you're gonna end up dividing everything by 7. So if it's easier for you to do that, you could. So let's go back to this point right here. So if we times by 7, we got 7y minus 28 equals 2x minus 12.
Yeah.
So then 7y equals 2x plus 16.
Yeah.
And then we divide everything by 7, and y equals 2/7x plus 16/7.
So you're still gonna fraction that away.
Well, you're actually doing what you did. You don't have to actually work with the fraction,
Yeah.
but yes, ultimately your answer will end up with a fraction. So if it's easier for you to do that, just remember you have to eventually divide it back out. But at least I didn't have to worry about adding fractions here.
Okay.
So if that's easier for you, it's fine, but you still want to end up with this. Okay? Good point. All right, let's do the last one here, B, 3B. So we have this point and this point, and we're going to do exactly the same thing. So what are we going to do first? Find the slope. So the slope will be 5 minus 2 over 5 minus 3. I got 3/2. Okay? Mr. Hankins, what happens next? I'm writing the equation of a line using the point slope form, which is right here. I'm using this form right here again. So now I have figured out that m is 3/2. What now? What am I going to distribute? So there's going to be a distribution here, but I have to plug something else in first. What do I need to plug in first? I need to plug in these, right? So where do I get those? Here's my problem. So I'm going to pick one of these, right? I don't care which one you want to use, makes no difference.
Well, you end up with the same problem.
Use 3, 2. And the question over here was, does it matter which point I pick? And the answer is no. As miraculous as it sounds, this stuff will look different, but ultimately, you're going to end up with exactly the same answer no matter which point you pick. So he used 3, 2. So Matthew, y minus 2 equals 3/2 x minus 3. So y minus 2 equals 3/2 x minus, what do I get here when I multiply? Not 6 over 2. I get 9 over 2. Yep, I get 9 over 2. I'm multiplying. So now I'm going to add my by 2. So I have a negative 9/2 and a positive 2 over 1. So I'm going to multiply by 2 here. So I have a negative 9/2 and a positive 4/2. So someone said negative 5/2, and I think that person's right. Yes, ma'am.
For the next one. If the quickest way to get to self-intercept, do you have to put up my stuff and then get to self-intercept?
No, but that will work because ultimately I ended up here. Can you hang on to that question until tomorrow? And we'll start with that tomorrow, remind me, because absolutely, I can tell you like point slope, it'll work every time. Ultimately, you're gonna end up with your slope intercept form, even though you didn't use that form at all in the problem. Okay, but yes, it will work. All right, so now we need to do a quick review. Let me make a notation that we're stopping there. So we'll pick up there next time we're together. And let's do some review for a quizzy poo next time we're together, which will be what, Thursday?
Yeah.
So, in a long time between now and Thursday, you might want to write this down and take a look at it before you walk in here. We will not do a practice quiz before the quiz. I'm doing it now. This is it. This is your practice. So write it down and look at it again before Thursday morning when you walk in and I hand you a sheet of paper. All right, so we're going to have 2 points. Here they are. We're going to do 3 things with those 2 points. First thing we're going to do is this. Second thing we're going to do is this. And the last thing we're going to do with that is this. All right. What's that mean? Distance. So you need to know how to find distance. We talked about this the other day. Distance is the big radical. What goes under the big radical?
X minus X1.
So I can do 5 minus 3 squared. I'm subtracting my x's. 5 minus 3 squared
Plus 10 minus 4
plus 10 minus 4 squared. So I subtract my x's, square it. Subtract my y's, square it. Add them together and take the square root.
Yep.
I do the arithmetic. 5 minus 3
2,
squared.
4,
10 minus 4,
6,
6 squared.
36.
And then I pay attention to the radical. Sometimes it breaks down, sometimes it doesn't. I do not have my handy dandy little yellow cheater calculator. I gotta be able to do this by hand. Square root of 40. Got it right down. It does, because it's 2 times 20, which is 2 times 10, which is 2 times 5. So there's a pair, right? So the 2 comes out. I have a leftover 2 and 5, so those stay in. There is the answer to the question. Anybody have an issue there? We're good? All right. Midpoint. Go back to these 2 points. How do we find the midpoint? Add them together and divide by 2. We're thinking average. We're going to average. So what is my average x? 3 plus 5 over 2 gives me 4. 4 plus 10 over 2 gives me 7. So my midpoint is 4 comma 7. Right?
Yeah.
M. That's the letter we use for slope. We just talked about this today, but we're going to have a quiz on it next time because you've done this for a long time in your life. You want to find the slope.
Yeah.
So we'll go back to our original 2 points. 10 minus 4, that's y minus y, over 5 minus 3, x minus x. So that's 6 over 2. So this line has a slope of 3. So there are the first 3, well, there are 3 questions on the quiz right there. All right? What else? Well, I was not real excited by the exponent production on yesterday's quiz, so there'll probably be another exponent question. Eventually, we're going to get to a chapter on logarithms, and you've already studied logarithms, and you know that you can't do logarithms if you can't do exponents. So we got to make sure we know how to handle exponents. So we want to simplify this. So here we go. First thing I need you to wise notice is a 5 over a 10. Now, I'm not subtracting. That is a fraction. 5/10, which reduces to 5
No,
tenths.
one half.
Oh my, 5 tenths. Take it out of the problem if you need to. That reduces to 1/2. Well, some of you said that. Other people said 2/5. 1/5. Those were various answers that I heard. Now, what about the x's?
You take the bottom x.
This guy
Move the negative 4 down.
has to come down.
So it'd be x to the 11th.
Think about it. There are 7 down here already. You are dropping 4 more down. So that would be x to the 11th on the bottom.
And then y squared. Y squared.
Now, nothing moves here, but you have 3 of them over 5 of them. So when you start canceling them out, you're going to be left with 2 on the bottom.
What if, like, there's like on the last quiz, there's like x to the 5th over x to the negative 5th.
X to the 5th over x to the negative 5th. Well, anything that has a negative exponent. Hey, guys, I'm looking at the clock. It says 8:49. I am trying to answer one of your classmates' questions. I find your behavior extremely disrespectful. Now, remember, you don't get to go till I tell you can go anyway. So just let me finish talking, all right? Just let me finish talking, and then it'll be time to go. First thing we always do is take care of the negative exponents. I mean, I would suggest that, take care of the negative exponent. Since this one is already in the bottom, he would have to move to the top. Well, wait, there's already 5 of them up there, and we're bringing up 5 more. So that will give us a total on the top of x to the 10th. And that, since that was it, there's nothing on the bottom. Now, in a problem like this, there might be something else down there, but that's it. Okay? All right, I will see you on Thursday for a quiz over all of this. I'm gonna stop that. Okay, good. Are you sure? Yes.